Data transformation is crucial in converting raw, messy data into structured formats for analytics. It involves cleaning, formatting, and structuring data for dashboards, reports, or machine learning models. This process ensures data is usable and reliable, setting the stage for effective data processing and analysis. Transformation operations are vital in data engineering. They include filtering irrelevant data, deduplication, and format correction, such as converting sales data to a standard currency. Deriving new metrics like total revenue or growth is also crucial. These operations ensure data is clean, consistent, and ready for processing, enabling accurate analytics and reporting. Processing involves applying transformation rules at scale. Data engineers choose between batch, microbatch, or real-time processing. Batch processing using tools like Apache Spark and Amazon Web Services Glue handles large data volumes at scheduled intervals. This method suits environments where immediate accuracy isn't crucial, ensuring efficient data handling and transformation. Stream processing is vital for real-time data insights, especially in finance, e-commerce, and Internet of Things. Tools like Apache Kafka and Spark Structured Streaming enable continuous data processing with low latency. This approach ensures timely decision-making by processing data as it arrives, crucial for applications requiring immediate responses. Ensuring data quality is vital in processing. Validation checks and transformation rules catch issues early, preventing bad data from leading to poor decisions. Automated rules can trigger alerts or quarantine data for review, maintaining data integrity and reliability. Data lineage and transparency are vital for trust in data. Documenting transformations ensures users understand data origins and changes. Metadata tracking and audit logs provide traceability, crucial for reliable analytics. This transparency builds confidence, enabling informed decision-making and fostering a culture of data-driven insights. Encoding business logic during data transformation clarifies data meaning and standardizes metrics, forming the foundation for consistent business reporting. This process ensures that customer categories are defined, revenue is calculated, and metrics are standardized, enabling reliable and meaningful insights across departments. Building reusable pipelines involves modular and declarative approaches, ensuring efficient data transformation. Orchestration tools like Apache Airflow and Dagster manage task sequences, ensuring they run in order and handle failures. This approach enhances scalability and maintainability, crucial for consistent data processing and integration with cloud-based transformation tools. Cloud-based transformation leverages environments that abstract data processes. Tools like dbt integrate seamlessly with managed services, enabling SQL-based transformations. These transformations benefit from version control and testing, ensuring data integrity and reliability. This approach simplifies complex data workflows, making it easier for engineers to focus on refining and enriching data for meaningful insights. Data transformation refines and enriches raw data, making it insightful and decision-ready. It prepares data to drive innovation across organizations, ensuring it is organized, reliable, and meaningful. This crucial step bridges technical expertise with business understanding, fueling insights and decisions that propel organizations forward.